Okay, so for today, we will concentrate on the discussion on the creation of our exam. Okay, and please remember that today, right? Sorry. Today you will have an exam at 2 p.m. Okay, in the afternoon, and as I told you before, the topics which will be covered is actually all the topics, but the concentration will be from the frame and machine until the internal force and moment. Okay, internal force and moment diagrams. So actually, those are the topics which will be covered in the our second midterm exam. So all the topics, but the concentration will be from frame and machine until the internal force and moment diagram. Okay, and for that one, right, as usual, whenever it's close to the exam, I always try my best to help you guys to prepare for the exam. So for this particular class, I will dedicate this particular class only for the discussion of the second midterm exam. Okay, so I believe you guys already studied a lot about it, and I'm not so sure whether you have any question about it. And if you have any question about the second midterm exam, all the topics which will be covered there, please let me know so I can discuss it today. Yes, no one? No one want to ask question? No? I think in that case, what I will just try to recall, to review all the things, which is which will be covered in the exam. Okay. Let me share the screen. So the first thing that which will be covered, the first thing that will be the main topic of the current exam will be a frame and machine. Okay, frame and machine. Frame and machine is actually continuation from the previous topics, which is the truss, right? In the truss, all the members, okay, in the truss where all the members is supposed to be a two-force member, but in a frame and machine, okay, if you find a member, at least a member which is a non two-force member, or we can call it as multi-force member, then it must be either frame or machine. Okay, it must be either frame or machine. So the definition of frame and machine is if a structures have at least one multi-force member, we can call it as a frame or machine. What is frame and what is machine? Okay, when we have a mechanism, normally we call it as a machine. But when it normally only holds the weights or certain weights like that, we call it as a frame, like that. Okay, and I believe you all already, yeah, this is some example on the frame and the machine, right? Okay, and this is the flow chart from Pak Ferry, but the flow chart is correct. Actually, you're supposed to follow the flow charts in order to solve it. solve the frame and machine problem, but not necessarily you have to follow all the steps like that. Okay, some of the problem there I already discussed before, right? And this is part of the machine that we already discussed before. So there are a lot of problems which I already discussed previously regarding related to the frame and the machine. Okay. And some problems I put it there in your homework as well. This one I believe I already explained it as well, right? And yes, there are a lot of problems which we already have discussed before. About frame and machine, is there any question? Nuki, do you have any question, Nuki?
Currently, no, sir, but I'm still trying to connecting my brain to its function.
Can I ask simple question?
Oh, yes, just of course, Rizky.
When you have a like quadratic function, how to know?
So it's about distributed force then.
Yeah, for distributed force.
Yes.
How to know when to draw it? Like U or I mean how to describe it ya. Kalau di Indonesia cekung ke dalam dulu baru ke atas atau kayak bikin terbalik gitu lintasan.
I think I understand what you mean about it. So for example, if we have a actually your question is, I believe it's more more to the internal force and moment diagram instead of the distributed force, right?
Yes, it's for the diagram.
Okay. I think I can discuss about it. So so basically maybe we can just use this. We can just use this particular example. Sorry. Keep stop share and then share again. So basically, if we have a distributed force like this, right, 6 kilonewton per meter like that, most likely the internal shear force distribution will be linear. Correct, Rizky?
Yes, Pak.
Yeah. So the internal force, internal shear force distribution will be linear, and then the internal moment distribution, it will be quadratic. Correct, Rizky?
Correct, Pak.
Yeah. And your question is, for example, if we have this kind of distribution, later for the internal moment distribution, how can we decide whether the curve will be like this or like this, right? Correct or not?
Yeah, something like that, Pak. Sama like if it's positive, there will be dua skenario, Pak, di mana kayak gimana ya? Kayak gambar U terbalik dulu atau kayak mau gambar U sebagian yang bagian kanannya gitu loh.
Okay, then. In that case, I think I will try to continue with the discussion on this, right? This is quite simple. the discussion on this, but maybe we can use this as an example. So basically, as you can see here, we already calculated the AY and BY values. If we have a 6 kilonewton per meters distribution from A to the middle, okay, from point A to the middle like this, okay. So I believe we can draw the free body diagram, okay, because we already know the values of AY and BY. So later, the final free body diagram is supposed to be like this, right? Okay, AY is supposed to be 1.35, BY is supposed to be 0.45. 1.35 kilonewton. And the distribution is 6 kilonewton per meter. 6 kilonewton per meter. Okay, Rizky, because you are the one who asking this. Okay, 300 millimeters. So here from here, 300. 300. Because you are the one who asking this, right? Please help me to do this, okay, Rizky?
Okay, Pak.
So for this one, how many sections are we supposed to do?
Only two.
Only 2 sections is correct. This one and this one. This is our first section, and this is our second section, right?
Yeah.
Then the next thing that I suppose that we supposed to discuss, how we supposed to draw the first free body diagram of the first section, the free body diagram of the first section.
The first section just draw just
Something like this.
until the distributed force end.
But we don't have to
300 millimeter. The first
no, yeah, but we don't have to draw the 300 millimeters, right?
Yes.
Because it's always in the value of X, right?
Yeah, yeah.
So we have 1.35 kilonewton. What else that we have there?
Distributed forces
Distributed force
of 6 kilonewton per meter.
6 kilonewton per meter. What else?
And normal force, shear, and moment.
Normal force, shear, and moment. I will not draw the normal force because there will be no normal force. Yes, so I will only concentrate on the shear force, phi, and the moment. Okay, that's the positive direction, right? Based on our previous discussion, right? So now we can try to calculate that. Okay, if the distance here is x, right? Okay. Now I want to calculate the so for this one, the equation, all the equations supposed to be okay from 0 until x equal to 300 millimeters, right?
Yes.
Okay. So now, which one that you want to calculate first, phi or m, the shear force or the moment?
I think the phi is
the phi. Okay, the shear force. Then, if we want to calculate it using sigma Fy equal to 0, what we supposed to have there?
There will be 1.35 kilonewton.
Okay, so going up is positive.
Minus phi.
Minus phi.
Plus 6 times 6 times x.
Plus or minus?
Minus 6x.
Minus, right? Minus 6 kilonewton per meter multiplied by x, right?
Yes.
Equal to 0. Okay.
Okay.
So what we have there is we will have phi equal to what is that?
Equal to 1.35 kilonewton.
1.35 kilonewton
minus 6x.
minus 6x, right?
Yes.
Now the last one, the next one, because for this one, in order to answer your question, I will not draw the second section. I will only draw the first section, okay? Because the second section, there will be no quadratic moment there, right?
Yes, exactly.
Only the first section there has the quadratic moment. Now,
Yes.
in order to find the equation for the moment m, what equation that we're supposed to use?
We'll use the sigma moment from the right side.
Okay, sigma moment from the right side equal to 0. What we have there?
It will be 1.35 kilonewton times
1.35 multiplied by x. What else?
I think it should be minus 135.
Oh, why is supposed to be minus 9? It's okay.
Never mind. Yeah, it's okay,
Okay.
but
Yeah.
minus m.
Okay, minus m. What else?
And after that, minus
okay, in order to help you, I will draw it like this way.
There will be an r.
Yeah, let's consider it force it will be
x.
yeah
6 times x.
6 times x.
And multiply it by x over 2.
So minus, right? Minus x, sorry. Minus 6 times x is the force, right? This one is the force.
Yeah.
Multiply by the momentum. What is the momentum?
The moment will be x over 2.
X over 2. Okay, that's all, right?
Yeah.
Equal to 0. So in this case, what we will have later will be m equal to what?
It will be m equal to 1.35x.
1.35x minus
m. Never mind.
Yeah,
the m already moved.
Minus 3x square like that.
Yeah.
Okay. Now, I will be asking. I'm asking you about this. If the question is like this, the curve will be like this or like this for the moment.
Will be positive minus. I think it will be declining.
This one, yes, because it's minus the. Everything will depends on this, right? Everything will depend on that. The x squared, the constant of the x squared. If the constant of the x squared is positive, then it will be like this. If the constant of the x squared is negative, then it will be like this.
Okay.
Going down. Okay. Now we know that it will be like this, right?
Yes.
Okay. Now let's try to draw the equation. So the first one is minus 6x. So basically, I think I will draw the phi first. This one is phi. Okay. This one is phi. And then for the phi first, how I supposed to draw it?
For the phi, it only 1.35 minus 6x.
At x equal to 0, what is the value of phi?
At x equal to 0, 1.35, so it will start at 1.35 on the phi.
Okay.
And it will go down.
5
and it will go down
kilonewton
until and it will go down until 6 times 300.
Yeah. You have to remember just now when we derive everything, okay, we multiply 6 with x, and
Yeah.
there x is supposed to be in meters. Why x is supposed to be in meters? Because 6 there, the unit for 6 there is supposed to be kilonewton per meter.
I see.
So this one is not supposed to be 300, but you're supposed to put it as 0.3 meters.
Okay.
Don't forget about unit, because later the results will be weird, right? 1.35 minus 6 multiplied by 300, right?
Yes.
It's not supposed to be that way, right?
Yes.
Okay, Rizky. So for everyone, please be very careful about it. When you use the unit, you're supposed to take a look at the value of the distributed force that you use. Okay, 0.3 meters, just the same. Now, what is the value at x equal to 0.3 meters?
It will be
Minus, right?
yes, it will be minus 1.8, I think.
1.8.
Wait.
Yeah, this one is minus 1.8, but the total phi, what is the value of phi? Minus 0.45, right?
Yeah.
Minus 0.45. So
Yeah.
it will be here at this particular point, there will be minus 0.45. So around here. So this is it, right? So that is right.
Yes.
Okay. Now let's try to draw for the moment. Yeah. Let's try to draw for the moment. So for the moment, I think we can use the previous one. We know that the distribution will be like that. And now you can check as well at x equal to 0. What is the value of m?
At x equal to 0, it will be 0.
Okay. And then at x equal to 0, the moment will be 0. Then at x equal to 0.3, what is the value of the moment?
It will be 1.35 times 0.3 will be 0.4.
Use your calculator. Don't forget to bring your calculator. Okay?
Yeah,
Don't use your phone. What is the value there?
0.4 minus 3. 0.4 minus 0.27. 0.13, I think.
0.13.
Yeah.
0.13. Let me check. 1.35 multiplied by 0.3.
0.135, sir.
0.135. Okay. That's the moment. Okay, but now you still don't know the distribution, right?
Yes,
That's
exactly.
good. Okay, you still don't know the distribution. Okay, it depends actually how much time that you have in order to solve this, right? Actually, if you have plenty of time, you can try to analyze. Okay, the location of the maximum. Okay, the location of the maximum is where the phi value is supposed to be equal to 0, right? Because the gradient is equal to 0 there. Correct,
Yeah.
Rizky?
Correct, Pak.
So the phi will be equal to 0 when what is the phi will be equal to 0 when x is equal to what?
1.8 meter.
Minus 6x, right?
Yeah.
Okay. So we can try to find the x like this, right?
Yes.
What is the value of x here?
Value of x will be 0.225.
0.225. So this is the value where x is equal to 0. Sorry, this is the value where phi will be equal to 0, right? This is x value. When this is the value of x which cause phi equal to 0, right?
Right.
And at the same time, it will cause the moment to reach the maximum value. Correct or not?
Correct, Pak.
Yeah. So in that case, right, we can just try to recalculate what is the value of m at this particular point.
Okay. And the value of m will be at 0.225. Yeah.
What is the value of m there?
The moment, okay. Minus 3, 0. It will be 0.151.
0.151.
If I calculate it correctly.
I think so. I think it's I think it's quite accurate. So this one, don't forget about the unit is supposed to be Newton meter, right?
Yes, Newton
Don't
meter.
forget about the unit. So the value here will be 0. Okay. Then at the end it will be 0.135. So roughly here. Okay. And at the peak, it will reach 0.151, like that. So later your graph will be like this. Yeah. Something like that. You get it?
Pak, should the unit be in kilonewton meter?
Kilonewton. Sorry. Yeah, it's supposed to be kilonewton meter. And just now the phi is supposed to be correct, kilonewton meter. So this one is 0. This one is 0.151 kilonewton meter. This one is supposed to be 0.135 kilonewton meter. You get it, Rizky?
Yeah, I get it clearly, Pak.
Okay. Later, if you calculate again, right, in the second section, okay, the value of the phi, it will be minus 0.45 constant until the end. Okay, 0.45 constant until the end. Then the value of the moment value, okay, it will be keep going down from 0.135, okay, 0.135 until 0, 0.135 until it reaches 0 at the end. Something like that. Do you get it, Rizky?
Yeah, I get it, Pak. Pak,
so this is,
I want to ask, so to find the maximum point, you can just use 0 equal to the v function instead of deriving the m function.
It will be the same.
Oh, it will be the same.
So let's try. dm per dx. What is the value of dm per dx there?
Dm per dx, it will be 1.35 minus 6x.
1.35 minus 6x. What's the difference between this?
I see. Okay. It is always like that, Pak.
Yes, of course. Because from the beginning, right, I told you that the phi value is supposed to be the first derivation, the first derivative of the m value, right?
Okay.
But in order to make it safe, don't use that directly. So it's better for you to do the section method one by one instead of using this. But the whole phenomena is supposed to be like that.
Okay. Okay.
Okay. Okay, Rizky, you understand now?
Yeah, I do.
Okay. Anyone else have any questions about this? This is
Sir,
about the distribution. Yeah. Who's this?
Irfan, sir.
Yes, Irfan.
To ask about the notation for the signs for the zero, the x between 0 and 0.3. So it's
Mhm.
so the sign, is it always like that, or do we have to put an equal sign also? Sir?
I don't understand. Your voice is little bit unclear like that. Yeah. Say again.
Sir, so the x is between 0 and 0.3, right, sir?
Mm-hmm. Yes,
For
yes.
the notation, for the sign, is it like that, or do we have to put when do we know if we have to put an equal sign?
No,
Less
no.
than.
Don't. I think it's better for you to not put the equal sign there.
Oh, so it's always like that, sir.
Yeah. Mhm.
Okay.
Because sometimes, remember, right? Whenever we have a concentrated force, there's always a jump there, right? There's always a jump like this, concentrated force. So,
Yes, sir.
I think in order to make it safe, I think just put it like this. Because we don't want to consider the jump like that.
Yes,
Okay, so just put
Okay,
it
sir.
that way. Because sometimes it will the value will change directly rapidly from one value to the other point because of there is a concentrated force or concentrated moment. So if you put equal there, it will not actually it will not cover that particular point like that. Okay, it will only cover just slightly before that point, and after that, for the next equation is for the slightly after that point, right?
Also, it's not equal to the jump itself, sir.
Yeah, actually, in order to make it safe, just use this.
Okay.
Just use the
Thank you, sir.
inequality. Yes. Any other question about this?
Sir,
Mm-hmm.
is
What's
it
this?
okay? Azhar.
Okay, Azhar. Yes.
Is it okay if we don't have we really don't have time to write the zero lebih ke the batas, the boundaries?
Mm-hmm.
Is it okay if
Is
we
it okay
don't?
for?
Is it okay if we don't write the boundaries
No,
zero?
no, no. It's you have to write it down because it
Oh,
means because when you have to let everyone knows that this particular equation. So we have two equations. Right? This is the first equation for phi, and this is the second equation for m. Okay. So we have to let everyone knows those two equations works for which region like that. So these two equations only work for this region. Okay, because for the other region, we have the other region from 0.3 meters until 0.6, right? 0.6 meters. For the other region, the phi there is supposed to be equal to minus, so it's minus, what is the minus 0.45 kilonewton. This one, 0.45 kilonewton, right? The phi there is supposed to be minus 0.45 kilonewton. Okay, and the moment it will be constantly going down from 0.135 kilonewton until it reaches zero at x equal to 0.6 meters. Do you understand?
yes.
Mm-hmm.
Oh, yes. But I'm still a little bit confused. If we cut it from the right, how do we notate it, sir?
if we cut it from the right, okay, if we cut it from the right, you mean this one, right? Yeah,
Yes.
let's try it then in that case.
How
Okay,
do we notate it?
for, for this one, right? Let's try to draw the free body diagram if we cut it from the right. If we cut it from the right, the main thing, if you want to cut it from the right, it will be just the X value. Okay, it will be just the X value. So we have, we have 1.45 here. Okay, 1.45, sorry, not 1.45, 0.45 kilonewton there. What else that we have in the free body diagram? Asar?
We have the we don't have anything else.
Yeah,
Only that.
but we have.
Oh, the shear and the
Yeah.
moment.
Sure. The positive shear is supposed to be going which direction here?
Clockwise.
Clockwise. So it's upwards or downwards?
Oh, the shear is upwards.
Okay. The shear is supposed to be upwards, right?
Yes.
This one, 3. How about the moment?
The moment clockwise.
Clockwise. Something like that. Now, the most important part is this one. The distance here. What is the distance there?
Is it x minus 0.3
Think
or
again.
0.3 minus x?
Nope, 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 nope.
No.
Remember, right? X is actually from the left side until the section. This is, we
Yes.
call it as X. Now, this is the distance that we are talking about, right?
Yes.
So what we're supposed to put it there? The length here is not 0.3, but 0.6. The whole length.
Oh, yes. So it's 0.6 minus x here.
Yep. It's supposed to be here. The length here is supposed to be 0.6 minus x, right? The same as here. 0.6 minus x. Okay, that's the most important part because that's the thing which will help you to answer the question. Okay. Now let's check again. I think I will just wipe this one down. Why I wiped that one? Okay, from from 0.3 meters x 0.6 meters. V is equal to minus 0.45 kilonewton. Now, for the moment, what we're supposed to do in order to find out the equation for the moment? Hello, Asad?
Plug in the
What
forces.
equation? No. What equation that we're supposed to use to calculate for the sigma moment? For the moment for this one.
Oh, you mean 0.5 minus 0.5 times 0.6 minus x, like that? I don't understand what you mean.
What I mean is this one.
Oh,
Sigma moment on the left side or the right side, like that.
Sigma moment left. I think, is it okay if I use the clockwise? Is positive?
Yes, of course. Then what we have there for sigma moment on the left side equal to 0?
M.
Then?
Minus 0.45
multiply by?
times 0.6 minus x
Equal to 0, right?
Yes.
Yeah. So your M will be like this, right? 0.45 multiplied by 0.6. What is the value of that?
0.27.
0.27 minus 0.45 x, right?
Yes.
Okay. Now you can check again the value of the moment at 0.3 meters. What is the value of the moment there?
At 0.3, 0.135.
Okay, why suddenly wait. I think we made a mistake here. Sorry, oh yeah, yes, correct. 0.135, right?
Yes.
Kilonewton meter.
Meter.
This is the value here, right? Correct, right?
Correct.
Yeah. And what is the value of moment at 0.6 meter?
0.
0. This is the value here. Okay. Correct, right, Hasan?
Yes.
So that's the way to handle that. As long as you do this correctly, this one, the okay, as long as you do this correctly, right, this one, everything is supposed to be okay, Hasan.
Yes.
Okay.
Okay.
So that's the way to cut it from the right. You know that the distance is x, okay, but sorry, you know that the distance from the left is x, right? Like
Yes.
this. The distance from the left is x. You know the distance from the left is x. Now the distance here is supposed to be the length, the whole length minus the x, right?
Yes.
Yeah. So that's the way it is.
Oh, okay.
You
Okay.
understand, Hasan?
Understand, sir.
Okay, good. Anyone else here want to ask question?
Sir, can I ask something?
Yes, yes. Who's this?
Samuel. Samuel, sir.
Samuel. Yes.
So, is x equals to 0 always be on the left side, or can it be on the right side too, sir? So from the right side.
Because we get used to it from the left side. It is better for us to just use
Okay, sir.
x from the left side, because if actually yes, you can create another coordinate from right to left, like that. For example, if you want to create a coordinates like this, okay, this is my x. Wait a minute. This is my x like that. But I want to create another x here. Okay, this one I, this one x, this one is c, for example. Yes, you can. But most of the time, when students do so, it will confuse themselves. It will confuse the student. So it's better for you to not doing it.
Okay, sir.
But if you ask me, can you do that? Yes, you can. But the way to draw it, you are not used to it, because the way to draw it is from right to left, right? You are not used to drawing something from right to left.
Yes, sir. Yes.
Okay. Anyone else here want to ask question? Yes, please.
Me, sir.
Yes.
Sir, when evaluating the shear, I'm all right if it's like the distributions like rectangular like that, but I'm kind of confused when it comes to the triangular kind of distribution.
Yeah,
triangular. Let's say if the distribution here is like triangular, like how would we like apply it in the shear calculation over here in the left side?
Shear calculation, it won't be that hard as well. So if it's triangular, then okay, for example, then if this one is triangular, right? I think I will just why I can't. I think I will add another one. Okay, so okay, it won't be that hard. If you want to make it as triangular, then wait.
Sir, I have a question. Sir.
Hello, can you hear my voice?
Yes, sir.
Yeah, sorry. Just now okay. So if it's triangular, it must be like this, right? So this is it. For example, if we have a triangular like this, what we're supposed to do with that? Okay, for sure, the first thing you have to calculate the reaction force at A and at B, because it will be different, right?
Yes.
Okay, then after that, the next thing that you're supposed to do is to calculate for the after you do the sections. Okay, if you do the section like this, right? Number one, number two. Okay, if you do the first section, for example, if you do the first sections like this, okay, you have reaction at A, then you have this moment V. For example, if we have 1 kilonewton here, right? Then
Yes.
the distribution. The first thing that you're supposed to do is you have to calculate for the maximum here at the right end, at the X, the value of X. Okay. So the distance here is X. So you have to, because previously, normally we have the value of W at the end there, right? Now you have to find out the value of W at X distance. Do you get it?
Yeah.
So for example, if the value of W here is 10 kilonewton per meter, for example, at this particular point, right? The value of the W is 10 kilonewton per meter. Then the value of W at X, it's supposed to be X divided by, for this one is the distance supposed to be maybe 0.3 meters, for example. X divided by 0.3 meters multiplied by 10 kilonewton per meter. Do you get it? So later, the value of the W there, it's supposed to be 30x like that. 30x. Do you get it? Hello?
Wait, so the 0.3 is the width of the distribution.
Yes.
And then,
So basically, this one is a mathematics. We just need to find out the value of W at X like that. Okay.
so it does not have anything to do with the location of the resultant.
It doesn't have anything to do with the
Location of
no,
the
no,
result.
no. It's not yet.
Not yet. Oh, I see.
Not yet. So you have to define this first. W, the value of the W at X. For example, like this. Okay. Then after that, yes, when you calculate for V, when you calculate for M especially, then you have to find out the this one. Okay. The resultant there. the resultant and the location. Okay. So for example, if we want to calculate for phi, right, using sigma Fy equal to 0, then if going up is positive, we have 1 kilonewton minus phi, 1 kilonewton minus phi, okay, minus the resultant, right?
Yes.
Yeah. And what is
Oh.
the value of the resultant?
The value resultant is
30x multiplied by the length here is x, right?
yes, and divided
Divided by 2. Like that, equal to 0. So your phi, it will be 1, right? Phi 1 minus
30x squared over 2
15x squared. Yeah, something like that. You get it, right?
Yeah. Also, so for the above, so although we cut before the end, we still consider the full length as in this one.
Why you mean the full length? No, it's not the full length.
In blue, this one, the W of x.
No, it's not 0.3 meters, but it's x. The distance there is x, right? That's why we call it, we multiply W, the value of W with x, right?
Okay, and the 0.3 below it?
0.3? No, I don't use 0.3 there. Oh, this one you mean? That
Yes,
one? Because I want to find out the equation, right? I want to find out the equation. What is the value of W at x, right? The value of W that I know is the value of W at 0.3 meters, right? How can we find the value of W at x by using the value of W at 0.3 meters if we know that the distribution is linear? Just by using comparison of distance, right? Do you get it?
Oh, okay, right.
So this one is comparison of distance in order to find the value of W at distance x, because the value of W that I know of is the value of W at distance 0.3. You get it?
Oh, yes, I get it.
So what we have to do is x divided by the length there multiplied by the W at 0.3. That's what I will get for the W at x, like that, because the comparison is supposed to be linear. So basically, the actual equation is supposed to be like this. The value of W at x is divided by the value of W at 0.3. Okay. Sorry, the comparison is like that. The value of W at x divided by the x is supposed to be the same as the value of W at 0.3 divided by 0.3. Because it's linear. Linear is supposed to be like this, right? So if I just moving around everything, this is what I will get. Do you get it?
Oh, I get it.
Something like that. Okay. So that's the first thing that you're supposed to do to find out the W value, the W value at x. Then everything else can come from there. Okay. For the moment, you have to remember that the distance of the resultant here is supposed to be 1/3 from the right or 2/3 from the left.
Sir, I have a question.
How
about when do we use W equals AX plus B like that? That one in what type of function?
You can use it as well. You can use it as well. That's just the same. This is the way, the same value, the same way as before as well. If we use AX, if we use W equal to AX plus B, this one is more general. So actually, you can use this one.
Okay.
The results will be the same. The results will be the same. But for this one, Okay, for this one, because the distribution is from 0 to maximum, then this one can be used as well. But if the distribution is slightly different, then it's better for us to just use this. Actually, this one is more general, so it can be used to any case. So it's better for us to just use W equal to AX plus B. Okay. Hello.
Okay, sir.
Okay. Then the next thing that I will discuss about is, wait a minute. Let me try to check. Stop.
And yes, sir. If the
Hmm?
find the moment for the triangle distribution,
Mm-hmm.
is that when we finally decide to use the 2/3 of the way?
Yes, correct. Wait a minute. Let me check. For this one, right? If you want to find out the location of the moment, sorry, if you want to do the calculation for the moment of this one, then we have to use the 1/3 from the right or 2/3 from the left. 2/3 from the minimum and 2 from the 0 values, 1/3 from the maximum values. For example, if I want to calculate for the M value, okay, I will use sigma moment. Okay, I will use sigma moment of the right side, for example, in this case, equal to 0. Okay, sigma moment of the right side equal to 0. Okay, for this one, what I will have will be clockwise positive. If it's clockwise positive, 1 kilonewton multiplied by x. Okay, then minus m, then minus the W, the concentrated force here. The concentrated force there, just now the value was the 30x, right? 30x multiplied by x divided by 2, this one, 15x squared. That's the concentrated force. Okay. The concentrated force, then
15x squared is already with the distance. Yeah. Or
wait,
not?
wait. No, not yet. This one, our distribution of the W is, the W value is 30x. No. This one, 30x, because the unit is slightly different than that. Okay, so this one is 15x squared, but the unit is in kilonewton. This one, so it's just the force only. So you have to multiply it by the length. Okay, this one is from the right side, so 1x/3 like that equal to 0.
Oh, because it's from the right.
From the right? Yes, correct. So
if we take moment from the left, it's going to be 15x squared times 2.
Yeah, the value will be the same. The value will be the same. The value will be the same. You are doing it from the right or the left, the value will be the same. So it will be x minus
or still multiplied
7.
by x over 3.
Yes. No, the value will be the same. The n equation will be the same, but you have to multiply it by 2x/3.
But the distance will be different.
Yes, the distance will be different,
I see.
but the moment equation will be the same. It will not change whatever equation. So from the left or the right, whatever equation that you use, it will not change the whatever side that you will use, it will not change the equation. Do you get it?
Oh yes. Oh yeah, because the ratio will be the same. I understand.
Yeah. So you can see here, because this one is linear, the distribution, the W is linear, the V will be quadratic. and the moment will be to the power of 3. Okay.
Also, I have to watch if it's left or right to decide if it's x over 3 or 2x over 3.
Yeah. So x over 3 is from the maximum. Okay. 2x over 3 is from the minimum, from 0 value. Always like that. Because it's a linear, right? Okay.
Oh, I see. Okay.
Okay. Then I think I will try to discuss as well about other things. Wait a minute.
Excuse me, sir.
Mhm.
I have a question, sir, but it's not related to the moment. It's more to the Freeman machine, sir.
Yes, yes. What is that?
What is the difference between thrust bearing and a journal bearing, sir?
You don't have to worry about that. If later, if we have, because we haven't learned, we haven't taught you guys yet about those, right? If later there will be a thrust bearing or journal bearing, there will be an explanation on that. So, for example, this kind of bearing will produce this kind of forces. Okay, this kind of bearing will produce this kind of forces. Okay, so you don't have to worry about it.
There will be an explanation, sir.
Yes, yeah, because the type of bearing, right? The type of bearing, we haven't given those information to you yet because you haven't taken any subjects related to that, right? So that's our responsibility. That's the lecturer responsibility to explain to you guys. Certain type of bearing will produce certain type of resultant force. Okay, but of course, if it's just normal, if it's just a normal roller or pin like that, you're supposed to know about it. Okay.
Okay, sir. Thank you.
Okay, now homework 11. This is the other thing that I supposed to give it to you guys. Wait a minute, share screen. Homework 11, right? Okay, guys, if you have this kind of problem, okay, in order to solve for the bending moment diagram and shear force diagram, normal force, bending moment, normal force, shear force, and bending moment diagrams, what things that you're supposed to do at the beginning? So before you do the other process, what things that you're supposed to do at the beginning? Would you mind to help me to answer this? Because it may, yeah.
Draw the free body diagram first, sir. The whole.
Draw the, yes, correct. Draw the free body diagram, but remember, okay, most of the time, you are only asked to solve for the horizontal beam, right? So basically, the free body diagram of this is unnecessary, and it is better for you to check first what forces or moment which is happening at those points due to this. How can we do so? Okay, how can we do so? Then anyone here have any idea on solving that?
Move the force first.
Yes, move the force first. So the first thing that you're supposed to do, right? Using all the things that we have here, try to calculate what are the forces which is happening at A and B first.
Yes.
Okay, so basically we have 8 kilonewton per meter for 1 meter. So here the concentrated force is supposed to be exactly in the middle, and the value of the concentrated force is supposed to be 8 kilonewton. Then here we have another concentrated force here, 1/3 from the right, 2/3 from the left. Just now Azir, right? What is the value of the concentrated force, the representative concentrated force for this particular triangle, Azir? Hello, Azir?
Oh, yes.
What is the representative concentrated force for the triangle distribution? Okay.
5 kilonewtons.
5 kilonewton, correct. And where is the position?
2/3 from two-thirds of a meter from
2/3
A.
meters, right? Yeah. Yeah, something like that, right?
Yes.
Okay, so using this, okay, using all of this, then try to analyze for the reaction force at A and at B. Okay, at A and at B. So basically we can find out the value of the reaction force at A, supposed to be AY, AX, BY, like that. And we have 8 kilonewton here. What else that we have?
The 6 and the 5 by couple.
Yep. For this one, right? We have 6 kilonewton and 5 kilonewton.
And don't forget the 5 part.
Yes, correct. 5 kilonewton here. So those are the forces, right? Okay, as usual, we can start with this one. Sigma moment at A equal to 0 in order to find By. Correct, right? Then after using this, we will be able to find By. I will not try to solve it because I want to discuss more problem with you guys, how to solve it, because the calculation is up to you guys, right? Then using sigma fx equal to 0, what we will have is ax there. Then using sigma fy equal to 0, what we will have is ay. So we will be able to find by, ay, and ax and ay, right? Then in order to build the final free body diagram, the next thing that you're supposed to do is just to isolate this in order to find out the forces, okay, the effect of the 6 kilonewton and 5 kilonewton forces at this particular location. Okay, because the effect of those two forces at this, okay, is needed in order for us to draw the normal force, shear force, and bending moment diagrams. And how can we find out the reaction here due to 5 kilonewton and 6 kilonewton? Anyone here have any idea besides moving the force? Okay. Actually, the easiest way, right? Actually, the easiest way is to draw the free body diagram and to solve it.
Also, we can isolate this.
Yes,
this
of
part,
course.
yeah.
Yes, we can isolate it. We can do it this way. 5 kilonewton and 6 kilonewton. Then we can try to find out the reaction force there. This one, what we call it, okay, call it as point C, right? Cy. Then we have Cx, and we have clockwise, counterclockwise, okay. And we have the last one, we're supposed to have, yeah. This one, moment, let's see. Counterclockwise. Okay, those three, MC, CY, CX, are the reaction which is happening there. Okay, using sigma fx equal to 0, what we will have is Cx will be equal to 5 kilonewton. Using sigma fy equal to 0, what we will have is Cy will be equal to 6 kilonewton. And using sigma moment equal to 0, okay, what we will have will be MC, okay, MC there is counterclockwise, okay, it's supposed to be 5 kilonewton meters plus 6 multiplied by 0.5, so 3 kilonewton meters, so 8 kilonewton meter. 8 kilonewton meter here is because the moment due to 5 kilonewton is supposed to be 5 kilonewton meters clockwise. The moment due to the 6 kilonewton will be 3 kilonewton meters clockwise as well. So if you calculate, then we will have 8 kilonewton meters there, MC, the value of MC there. Okay, then how should we draw the final free body diagram? The final free body diagram is supposed to be like this. The same as this one, but we have AY. AY here, so you're supposed to find the value first. We have AX. AX value is supposed to be going to the left, right? Actually. And we have PY. But you have to solve it first, right? AX, AY, PY. You have to solve those three first. We assume that we have, all these three values are known already. Then draw the distribution of the triangle. Then draw the distribution of the square here. Sorry, the rectangle. Okay, what else that we have? Then we're supposed to include these three there. But remember, because it's action and reaction, the direction is supposed to be the opposite.
Down and right.
Yes, instead of up and left, it's supposed to be down and left.
Right.
So the Cy here is supposed to be 6 kilonewton going down. Cx is supposed to be going to the right.
There's
The
a
value
moment.
is supposed to be 5 kilonewton. And the moment. The moment is supposed to be clockwise or counterclockwise.
I think it's the same counterclockwise.
Nah, opposite. Supposed to be the opposite of this.
Clockwise.
So supposed to be clockwise because this one is supposed to be action and reaction. Action and reaction is not just the forces,
I see, I see,
but
I see.
the moment as well. Okay, Rizky?
Okay, Pak.
So the moment there supposed to be 8 kilonewton meters. So this is the things that you're supposed to solve. Okay, but remember AX, AY, BY there is supposed to be in certain value after we solve for this one. Okay, that's the thing that you're supposed to do in order for us to solve this kind of problem. Okay, always try to transfer, always try to find out the forces which is happening at the beam. Okay, you can just move the force, or you can try to do like this. I believe this one is the easiest way. But remember action and reaction. Okay. Any question about this?
Sir, I have a question, sir.
Who's this?
Samuel.
Yes, Samuel. Yes.
So, what if we're too lazy to do this, and then we just use the left and the right to avoid this thing, sir?
What do you mean by the left and the right?
So there's like, 5 cuts, right? 5 cuts.
Sorry.
There's like 5 cuts for this.
Oh yes, yeah. Yes, you can.
Yeah. So we use.
I will be lazy as well to do this. Okay. So most of the time when I do this problem, for sure, this the first three cut, okay, the first three cut, I will do it from the left.
Yes.
Okay, the first three cut, I will do it from the left. Okay, the last two cut is up to you guys. You can do it from the left or you can do it from the right as well.
Oh, sir, but that if we use the for the third cut, if we use it from the left, we still need to count the 6 and 5 kn, right, sir?
Yes, correct. Yes, correct.
But if we use the third cut from the right, we don't need to
Yes, you
count
can.
the 5.
Yeah, you can. But remember, you have to calculate for this.
Yes. I understand.
So you can pick your own poison.
Okay, sir.
So you prefer to handle with the distributed force, or you want to handle the concentrated force? For me, I always prefer to handle the concentrated force because it's way easier to handle.
Okay, sir.
Okay. And try your best to do it from the left. Okay. But if it's too much, then you can do it from the right. So that's why normally I will always try to do more from the left than from the right. Because the possibility of us making an error from the right is bigger, right? Because the X is not directly X like that, but you have to, for example, like this one, we have the length is 5 meters, right? So this one, if we want to use from the left, okay, this one is just normal X. But if we want to use it from the right, like this,
5 minus
okay,
X, yes.
Yeah. So it's supposed to be 5 minus X like that. Okay.
Okay. I understand, sir. But
when I was at your age, I even do a crazier things. Yeah. Sorry. Yeah. Sorry.
So if you ever decide to to jump the gun, and then when we're done with the left one, we go to the right one. It start with the cut on 4, sir.
Yeah, it's up to you. You can use the right for the 4th and the 5th, or just for the 5th. It's up to you. Actually, it's seriously up to you. You can, yeah. It's preferable to do it from the left. Actually, you can solve everything from the right as well. 1, 2, 3, 4, 5 from the right, but it's too much, right? Because we are not designed, okay, for Indonesian people, we are not designed to handle things from the right. We are designed to handle things from the left. So that's why it's try your best to do it from the left until you can't. Okay, when you can't, then do it from the right. Okay. Any other question here? Okay, this one is friction, so it's not part of the
sir,
part of action. Yes.
I avoided using the I use the free body diagram the same as before. So like there's still the L beam and the free body diagram that I use when cutting at 3.
Actually, you can do it. You can do it that way as well, but you have to do it with more care, of course, because 5 kilonewton there, it will create a moment for sure, right?
Yes, sir.
Yeah. So it's up to you. You can do it that way. You can do it that way, but as long as you are being very careful, then you can. Yeah. Then it's not supposed to be a big problem.
Sir, also when we are secluding with this method, the distance of the 6 kilonewton will be 2 meters from the left there.
2
when
meters?
Calculating moment at the third section.
Yeah, no. It depends. It depends.
No.
Depends.
When secluding, sir.
Secluding is like what?
So you have relocated it at C, and there's an external moment at C.
Yes, correct. If you already move it at C, then it will start 6 kilonewton will start at C, 5 kilonewton will start at C, but At the same time, at C, there will be a moment, 8 kilonewton meters. Okay, but if you are doing it your way, right, without moving the force 6 kilonewton and 5 kilonewton, so you will still use in the case of you are still using the L-shaped beam, then in that case the location will still be here, and there will be no additional moment there. But the additional moment will come out when you do the section.
So in short, when x equals to 2.5, there's no moment exerted from by 6 kilonewton, right?
Yes, correct.
All right, thank you, sir.
Yeah, something like that. But for sure, for some people, they are prefer to do it that way. So the L is still there, but please do it with more care, okay, Matthew? Because the possibility of you making error there is bigger than if you move it to the C. Okay, as long as you are being careful, it's supposed to be okay.
Also, sir, for the shapes of the distributed force, is it only triangles and rectangles for now?
Yeah, I think it's better for you to just prepare for a triangle and a rectangle. For quadratic distribution, it will be too much.
Not too much. So will there be any?
Just let's see.
Oh, okay.
I cannot tell you the problem of the exam, but I think it's better for you to just concentrate on the constant and the linear one. Okay, because quadratic way, unless the number of section is only one section, then there is a possibility that we may give you the quadratic distribution. Because for quadratic distribution, right, the problem with quadratic distribution, the internal shear force, it will be to the power of 3, and the internal moment, it will be to the power of 4. So whenever the order is getting increased, right, the level of the difficulties is increased as well. Okay, but it's better for you to just concentrate on linear and constant distribution. Okay, get it?
Okay, sir. Thank you, sir.
No problem. Anything else for internal moment diagram?
Sir, I want to make sure about when and where should we cut. So if they're asking for the moment and shear for the whole free body diagram, that means we must cut it for between every 2 force, right, sir?
Not every 2 force. Between discontinuity, I think I already explained it.
I see, sir.
Yeah, so for this one, we have 5. I think if you are still confused about where you're supposed to cut it, and the number of section as well, it is better for you to rewatch the video for that section, for the which dedicated for the number of section and where to do the section. Okay, because I created one special video just for that, right? I think
yes,
I believe that I told you about it, right?
Yeah.
So
yes,
it's supposed to be between discontinuity. So for example, if we have continuous force like this, there will be no discontinuity in the middle of the continuous force. So so we can see that the discontinuity happen here because of the concentrated force at A. At B as well, there will be discontinuity because of concentrated force at B. Then here, there is a discontinuity because previously there is a distributed force, then suddenly it disappeared. So there is a discontinuity here. And then there is a discontinuity here because of concentrated force and moment. Then there is a discontinuity here because previously there is no distributed force and suddenly distributed force appear. And there is a discontinuity as well here. So we have 1, 2, 3, 4, 5, 6 discontinuity. And you're supposed to do the section in between those discontinuity. Do you get it?
Yes, sir. So it cannot be in the force itself, yes, sir.
No, it cannot be.
Okay.
So it's
Yes,
supposed to be
sir.
like this, this, and that. Okay. That's why from the beginning, I explained to you for the first section, for example, it will only work from x equal to 0 until x equal to 1. But remember, it's not equal, right? It's slightly before 1 and slightly after 0. Because we don't want to consider the part where it has a discontinuity. You get it? Because normally when we have a discontinuity, for example, due to the concentrated force or concentrated moment, in the moment or the force diagram, there will be a jump there. Okay? You
Yes,
get
sir.
it?
I understand.
Good. I think I can cover one more question. Rehana. Hello, Rehana. Can you hear me, Rehana?
Yes, sir. I'm masukin microphone. Yeah.
Are you feeling well already right now?
Kinda.
Okay. So you can attend the exam today, right?
Yes.
Sir, I have a
Yes,
question. And I was just making sure that in distributed force, when we want to calculate the moment diagram for the moment, sometimes I'm a bit confused that when we times it with x, the distance between the distributed force to the moment. So how to make
distance between the distributed force
and the moment, like in section force, if we calculate it from the right, it should be x over 2, right, sir? Or am I mistaken? I'm still a bit jumbled when you are explaining about distributed force before, sir. I'm sorry.
So what is your question actually? So if we have like this, so I have a simpler problem for like the problem before. If we have like this, so what is your question again?
When we try to calculate the moment diagram, when we want to, when it's on the distributed force part,
okay, so
I'm still a bit confused how to calculate the distance between the distributed force to the moment. I think for this part is a simple, right, sir? I think, but if it's a bit
so this one. So for example, if we have a like this and we have a distributed force like this, right?
Sure.
Okay, then we have Ay, and then we have V and M. Something like that, right?
Sir.
Your question is how to find M, right?
Yes.
So for example, I use sigma moment to the right equal to 0. Okay. After we find out the X and V, Ay and V values, right? Okay. And if the distributed force here is 10 kilonewton per meter, for example, right? Okay. The distance, okay. So this is the distance X, for example. Okay. So what do you think? Where is the location of the representative concentrated force here?
I think
Must be in the middle, right?
Yes, sir.
And what is the value?
X over 2, sir.
No, that's the distance. And what is the value of the resultant?
It's 10x over 2, sir.
And
10
not 10x over 2. 10x only. That's the resultant. I'm talking about resultant.
Oh, resultant.
The
Sir. Sorry,
distance.
sir. The
Yes,
distance
the
is x over
distance here.
2.
The distance
So,
is x
oh,
over
shit.
2.
Yes, sir.
Okay. When we talk
Yes,
about
sir.
the resultant is 10x. Okay, so when we calculate for the sigma moment to the right equal to 0, then we have ay, right? Multiply by x,
By
right?
x and
Yeah. And then phi, there is no moment arm there. Then what else?
and the
Minus
resultant.
m. Yeah. Minus m, right?
Yes, sir.
Minus
And minus resultant.
So the resultant is supposed to be 10x times
X
the
over 2,
moment
sir.
arm, x over 2 equal to 0.
What if the distributed moment is put in the middle of the bar, sir?
Distributed moment.
Distributed force, sorry, sir.
Huh?
This morning I'm kind of sleepy.
Distributed force.
If we put it in the middle of this bar.
I don't understand. So,
I mean, in the middle,
so
not on the side.
Oh, you mean like this?
Yes, sir.
If it's like this, now let's think about it. Ay, dy. If it's like this, how many sections that we're supposed to do
3,
in order
sir.
to solve this? Yes, it's 3
3, sir.
sections. So it's supposed to be. I think it's supposed to be the last question for today. So this one is number 1, number 2, and number 3, right? So, so in this case, you are talking about the section number 2, right?
Yes, sir.
If it's the section number 2, then we can draw it like this. Okay, 10 kilonewton per meter. So we have ay, then we have phi and m like this, right?
Yes, sir.
So for example, if this one is 1 meter, this one is 2 meters, and this one is 1 meter. Okay, so you just calculate it. Then in this case, from here to here is 1 meter, and from here to here is x, right?
Yes, sir. So the distributed force distance we use for the moment is x minus 1
x
over
minus
2.
1. So x minus 1. The length here is just x minus 1, right?
Yes, sir. X minus 1.
X minus 1. But the length later, if you want to use the concentrated force, this one, yes, x minus 1
over 2.
Over 2, like that.
Yes, sir. Okay, sir. Right, that's the question I asked. Yes, sir.
Yeah.
Okay,
So basically,
sir. It's already clear now.
Just try to draw it properly like that, and I believe by drawing it properly, you will be able to find the answer, right?
Yes, sir. Thank you, sir.
No problem. I think because it's quite close to 9 in the morning, I think that's all for our class today. Okay. I believe all the tools for you to answer today's exam, I already give it to you guys. So please try your best. You still have 5 hours to review everything. Okay. Please try your best to review everything, and then please don't be late as well, and be prepared at least 30 minutes before the exam starts. Okay, be prepared at least 30 minutes before the exam starts. So the exam today will start at 2 p.m. sharp, but this is the starting time. It is better for you to come before that. Okay, it is better for you to come before that. So by 1:30 p.m. it is better for you to already stand by 1:30 p.m. today. Okay, and please try to prepare for all the tools, pens, and all the papers as well. And most likely the way to do it is quite close to the previous one as well, the previous exam. So you're supposed to know about it as well. Okay, and then I think that's all. And try to do it by yourself, right? Don't try to cheat. Whatever you do, we will catch you if you cheating. Okay, don't post your answer after you finish all the answer. Don't post it in the WA group or Line group like that. Okay, try to do it by yourself. Don't give out your answer. Don't try to read somebody's answer as well. Okay, I think that's all for today. Any more question about the exam? Short question maybe? If no, I think that's all for today.
Sir, if there's like an extension from the pole, we need to split it then. So it becomes like the question before, there's an L-shaped beam on the middle.
Yeah.
So we need to split it first then.
You can split it, or you can do like what Matthew did. So it, both ways supposed to be okay, but splitting it up and try to find the reaction, and then moving the reaction to the beam by action and reaction. Remember action and reaction, okay? It's supposed to be safer. Okay, Aaron?
So when you split it at the point of this split, there's a reaction force and a moment.
Oh yes, of course. Yeah, depend on the case. Okay. But if you are not comfortable of splitting it, then if you are not comfortable of splitting it, then using Matthew's way without splitting it, so the L shape is still there, it's still okay. Okay, Aaron?
I'm sorry, but how do you do the other method? I don't know.
Without splitting it, just calculate it as usual.
Yes, sir. So you cut it at the force without splitting it.
Yeah.
Or
without splitting it. So just put the L there, and when you calculate the moment and everything, then calculate it from there. But if you are not confident with that, please use the splitting method. Okay.
Okay, sir.
Okay, I think that's all.
Thank you.
No problem. I think that's all for today. I believe I explained quite a lot about it, and that's all for today. Please be prepared for your exam well, and all the best for your exam. Okay, that's all.
Thank you very much, sir.
See you guys at
Thank you so much, sir.
At the exam. Yeah.
Okay,
Yeah,
thank you, sir.
Thank you very
Thank you,
much.
sir.
Thank you, sir.
Thank you, sir.
Terima kasih banyak Mas Satrio.
Sir.
Yeah.
Yesterday I forgot to mark my attendance. When can I ask for your
I think in that case, Thursday next week in the class, let me know at the beginning.
Okay, sir. Thank you, sir.
Okay, bye.